right, so when we are adding and subtracting fractions, we have to have a common denominator. Throwback to third grade, that's when like math got rough for everyone because of fractions, and finding common denominators. So, finding the least common denominator. Factor out each denominator all the way. List the factors of the first denominator, and then add any factors from the second denominator that are not already on the list. And you just have to have all of the factors from each denominator at least once. So our first problem today, all we're doing is finding the least common denominator. We're not adding or subtracting, we're just finding the least common denominator. So the first thing that we need to do is factor out of this first one. I can factor a 5x out of 5x squared and 15x. Let me zoom in some more. Zoom, 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 zoom. Okay, so I can pull a 5x out. 5x squared divided by 5x just leaves an x behind. 15x divided by 5x leaves a 3 behind. Okay, for our other fraction, x squared plus 6x plus 9, what multiplies to 9 and adds to 6? 3 and 3, and both positive. So x plus 3 and x plus 3. Okay, so if you haven't done your was it P4 was factoring?
Yeah, I think so. P5?
It was either P4 or P5. I don't remember. If you haven't done your factoring assignments, go do your factoring assignments. If you photomathed all of your factoring assignments and don't know how to factor, go back, redo them, figure out how to factor, and let me know if you need help factoring, because you are going to be in for a world of hurt for every math class you're going to take for the rest of your life if you still haven't figured out how to factor. Because I know you guys, if you are seniors right now, or if you're juniors, the first time you learned how to factor was Unit 7 of Algebra 1, which was supposed to have happened spring of your Algebra 1 year. Then you guys all cheated your way through geometry and algebra 2. Not all of you, but some of you. So, if you haven't figured out how to factor yet, figure it out. If you need help, let me know. I'm more than willing to walk you through it, but I'm not going to spend class time for everybody on that. Okay. All right. Next one. Our next thing we need to do is we need to find our LCD. So our least common denominator LCD. We need the 5 from right here. We need the x from right here. And we need this x plus 3. So that's my entire first fraction's denominator factored out. Then I already have one x plus 3, so I'm going to check it off, and I need another. So I'm going to put squared here, because that represents having 2x plus 3. So you can do x plus 3 squared or x plus 3 times x plus 3. You have to have everybody at least once. So your LCD has to have everything from your first denominator and everything from your second denominator. But they can share, so we don't need to have 3 x plus 3s. We only need to have 2, because this guy needs 2. So we have to have 2. That's why we have it squared here. But we don't need a third one, because he can just use one of the ones from the other one. Okay. So we will find more least common denominators on the back of this. Right now, the first example I have is adding and subtracting when they have the same denominator. So this is the first problem that we're going to do, is if they have the same denominator already, we can just add across the top of our fraction. So our denominator is going to stay the same, 3x plus 4. And we are just going to add together everything on the top of our fraction, and we are just going to combine like terms. So 3x plus 3x is 6x. And 2 plus 8 is 6. 2 plus 6 is 8. I had all the numbers in my head. I had all the right words, just in the wrong order. 2 plus 8 is 6. No, 2 plus... I need to open my eyes. 2 plus 6 is 8. Everyone good?
Yeah, I was wondering.
Okay, we all good? Okay, then we have to simplify out anything before we like come up with a final answer. We just have to check to see if anything can be simplified out. Can I factor either my numerator or my denominator? Yes, I can factor my numerator. What can I pull out of my numerator? A 2. So I can pull a 2 out, and that would leave behind, so divide out a 2, that would leave behind 3x. And then 8 divided by 2 would leave behind 4. So I factor the top now. Then this 3x plus 4 and this 3x plus 4 cancel each other out. So that's why we always factor at the end to see if anything's going to cancel. So my final answer here is 2, but there's one more thing I need to do because it is a rational expression. What else do I need to do? Yes. So I need to take the bottom of my fraction, and this one I'm actually going to like show you guys solving out. Take the bottom of my fraction, 3x plus 4, set it not equal to 0, and then we need to actually solve that out. Like, I want to show you on this one, and then you can do it in your head. You're going to subtract 4 from both sides. So 3x cannot equal negative 4. And then you divide by 3. So x cannot equal 4 thirds, negative 4 thirds. It's always going to be the opposite. So when it's like a two-step equation like that, it'll always be the opposite sign of this number divided by that number. So that is our final answer on this one. We still have to keep the x cannot equal negative 4 thirds because at some point that would have made the denominator 0, even though we canceled it out. Okay, questions right now? Wonderful. Let's go ahead and flip this over. And here is the meat of what we're doing today. All right, so adding and subtracting when we've got different denominators. Here are our steps. Find the lowest common denominator, least common denominator, whatever you want to call it. You need to rewrite each of your expressions so that they have that denominator. I will show you how to do that. They worded it out. To do so, multiply the numerator and the denominator of each fractional expression by any factors needed to convert the denominators. I'll show you. You just multiply the top and bottom of your fraction by the same thing. Then we're going to add or subtract the numerators. And then if possible, we need to simplify out at the end. I don't think either of these simplify out on the end, but I do think a couple on your assignment do. So, first problem here. We have x squared minus 10x plus 25, and then 2x minus 10. We need to simplify out those denominators first. So, this guy, what multiplies to be 25, adds to be negative 10. Awesome, Vivian. X minus 5 and x minus 5. Then for 2x minus 10, that guy can factor. We can pull a 2 out, and that'll leave behind x minus 5. Okay, our least common denominator. We need the 2. We need an x minus 5 for this guy, and we can use the same one for that guy, but then we need another x minus 5. So we need a 2, and then we need 2 x minus 5s. So this is our least common denominator. Okay, so this already has a denominator of x minus 5 and x minus 5. So all we need to add into that denominator is a 2. We're going to multiply by 2 over 2 in this one. And I'm going to bring this down to write what I've got down here. So 2 times x is just going to be 2x. And then on the bottom of my fraction, I'm going to use this factored version. I'll have 2 times x minus 5 times x minus 5. I made my fraction bar too long. Okay. My second fraction already has a 2 and an x minus 5. All it needs is another x minus 5. So how I get that other x minus 5 is I'm going to multiply by x minus 5 over x minus 5. The reason why we can do this is because anything over itself, so like x minus 5 over x minus 5, that would reduce down to 1 over 1. We can multiply anything by 1 and it won't change the value of it. So now, for my second fraction, I now have the denominator I want, the 2 times x minus 5 times x minus 5. And then on the top, I've got x minus 4 times x minus 5, and I'll need to multiply that out in a second. Make sure you keep those parentheses around. Okay. Any questions right now? Hey, we need to multiply out this x minus 4 times x minus 5. I'm just going to do that right here. X times x would be x squared. X times negative 5 would give me minus 5x. Negative 4 times x will give me minus 4x. And then negative 4 times negative 5 would be positive 20. What's up? You good? Okay. Then we can combine these guys together. So we'll have x squared minus 9x plus 20. Okay, so what I just did right there was multiply this out. Now I'm going to add back in the rest of my problem. So I have 2x is the top of my first fraction minus all of this. So I'm going to put it in parentheses because I need to subtract all of it. And then that's all over a common denominator. So I can go ahead and just write the denominator once now. So 2 times x minus 5 times x minus 5. Okay. We got one more step, and that's just to combine like terms on the top there and do that subtraction. So, writing things in standard form, we want our x squared first. So this is going to be negative x squared. Then we'll do 2x minus negative 9x. Minus negative is adding, so it'll be 2x plus 9x. That'll be plus 11x. And then minus this 20. At this point, we would want to see if we can factor that at all. You can't. I'm just telling you right now. But if you could factor, you would want to factor and cancel things out. And I'm just putting my denominator back on. You can leave your denominator in its factored version. questions right now? Right, we've got one last problem I want to do. It is an addition one, just because I wanted to have at least 2 examples where we had to change the denominators so you could see some different stuff that happens. Anyone still need this? Anyone still need this? No? Okay, speak now. Hey, last one we've got 3 over 5x plus 2 plus 5x over 25x squared minus 4. So we need to factor out the bottoms here. This guy is already factored. We don't need to do anything else with this. 5x plus 2 cannot be factored anymore. 25x squared minus 4 can be factored. If I see 2 terms, an x squared and a constant, and these are perfect squares, I know I'm going to be able to use difference of squares. So 25x squared minus 4 can be factored into 5x plus 2, 5x minus 2. Whew. Excuse me. Okay, our lowest common denominator. We need the 5x plus 2 for both of them. We need the 5x minus 2 for the second one. We don't need anything else. So our LCD is just 5x plus 2 times 5x minus 2. Meaning that our second fraction, we don't need to change at all. We only need to change the first one so it has the same denominator. So to get that first one to have the same denominator, we need to multiply it and get it the 5x minus 2 that it needs. So I'm going to do 5x minus 2 over 5x minus 2 for it. Okay. I'm going to move that 3 out front. I'm going to rewrite this as 3 times 5x minus 2. It's going to be easier for my brain to understand. And then I'm going to go ahead and, now that we have a common denominator, just make it all one fraction. So I'm going to put my denominator on here. That's my denominator I wanted. And my second one just stays plus 5x. Okay. From there, we need to distribute and combine like terms on the top to see if anything can combine. So 3 times 5x is 15x. 3 times negative 2 is minus 6. We still have our plus 5x. Combining that together, 15x plus 5x is 20x minus 6. And then at this point, you would want to see if that will factor at all. It will. We can factor a 2 out, but it doesn't make it so that anything can cancel, so you don't need to factor it if nothing cancels. So then we've got over 5x plus 2, over 5x minus 2. And that's our final answer. And I just realized we forgot to do something in the last problem, and there's something that we need to do in this problem. And that is we have to exclude any values for which our denominator is going to equal 0. All right, so for this one, x cannot equal. If we were to set these equal to 0 and solve, it would be negative 2/5 and positive 2/5. And then let's go back to this other one. On the other one, it's just x cannot equal 5. That's my bad for forgetting those. Hey, any questions right now? Okay, I'm going to go ahead and stop this recording then. Post it for our 3 friends that are gone.